Okie doke. So the second math video, and the focus now is balanced growth. Or it's the focus now actually is time, okay, and growth. Changes over time. Right, there we are. So first I'm just going to explain what do we mean by balanced growth. So in an economy with economic growth, we call growth balanced if all the state variables, things like capital, labor, productivity, are growing at constant rates. These rates may differ from each other and they may be positive, negative, or zero. So they're not all the same necessarily, they might be, but they're all constant. Okay. Often, our model economists will move towards a balanced growth path, BGP, over time. And often they might well approach that path. From any given starting point, they might be pretty close to it after 10, 15, 20 years. And then they stay close to it or get ever closer for the rest of time in the model. Okay. Hence, the BGP can teach us a lot about what happens in the economy in the long run. Okay, if we're interested in the long run, the BGP is good enough, basically. And since analyzing the BGP is always much simpler than analyzing the transition path, the general movement of the economy away from the BGP, or when it's not on a BGP, but when it's moving towards it, that's very complicated. We're mainly interested in the long run. The BGP is good enough, it's much simpler, so we just mainly study the balanced growth paths in this course. Okay, so that's balanced growth. But in balanced growth, we have all these constant growth rates. Okay, but what is a growth rate? Well, we say that a variable y is growing at a constant or exponential rate g if we can write y of t is e to the gt, where e, of course, is 2.71, blah, 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 blah. Okay. So that's the definition, one definition of constant growth. To get another definition, let's differentiate that and say that differentiate an exponential. Well, the first thing we say dy dt, just a bit of notation, we call that y dot. Okay? Y with a dot on top, and we say y dot. Right. And what is y dot? It's g e to the gt, isn't it? I hope we all know how to differentiate an exponential. But of course, differentiating like an economist, it's just gy. Yeah? And that tells us straight away, well, y dot is gy, y dot over y is g. So another way of defining constant growth is when y dot over y is constant. And y dot over y is the growth rate of a variable, y. Okay, so what? Yeah. Okay, so that is a bit of very basic stuff about growth and balanced growth. Okay, but how do we characterize a BGP, a balanced growth path in general? Well, of course, there's as many balanced growth paths as there are models, so you could maybe think it's hard to say anything general, but actually there is something general we can say, which is that very often we start by assuming that a balanced growth path exists, and then based on that we can actually characterize it. So oh sorry, I'm going to pause this. I changed these notes and then something's gone wrong. Let me just pause. Okay, I hope that pausing worked right. So I've redone the notes here. So to characterize a BGP, we assume it exists. Imagine, for instance, an economy where one of the equations is as follows: y dot equals got x1 minus k, where x1 is variable but k isn't. Now, if we're on a BGP, we know that y dot over y is constant. Oh, sorry, I need to update this again. Let me try and find the pause button. Okay, I think this is recording again. I hope so. So, yep, we've got, I keep making careless mistakes in the notes. We've got y dot is x1 minus ky. Let's assume we've got that. Okay. And then we know that if it's a BGP, y dot over y must be constant. But we also know that y dot over y is x1 over y minus k. Okay? K is just a number. So we know if this is constant, this must be constant. But for this to be constant, we must have that x1 dot over x1 equals y dot over y. They must be growing at equal rates. Otherwise the ratio of them won't be constant, will it? If one's growing at 5% a year and the other at 2% a year, this ratio won't stay constant. So we know that on a BGP, x1 dot over x1 must be equal to y dot over y. And again, there's a mistake in the notes which I need to correct. Ah, crikey. Okay, sorry. Yeah. So of course it's the growth rates that have to be constant. If x1 over y is going to stay constant, they must be growing by equal percentages per period of time. So that means x1 dot over x1 must be the same as y dot over y. Okay. So that's just an example of how we can start to characterize a balanced growth path. If we have that upper equation in our model, then we know straight away that on a balanced growth path, x1 has to grow at the same rate as y. Okay. More on time, differentiation with respect to time. Okay. Assume an economy in which y equals x. What can we say about y dot? Well, clearly y dot must be equal to x dot. Okay, mathematically dy dt equals dx dt, y equals x. But what if we have y equals x squared? Well then, it's actually another version of the chain rule. If y equals x squared, then dy dt is dy dx dx dt. Dx dt is just x dot. Dy dx is just 2x. So it's 2x times x dot. Or, doing it like an economist, it's 2y over x times x dot. So that's 2y over x, x dot. So y dot over y, bring this over, is 2x dot over x. So that 2 shows up here. Y is x squared, y dot over y is 2x dot over x. Okay, so far so good. What about a more complex case? Y is a x1 to the 1 minus alpha minus beta, x2 to the alpha, x3 to the beta. What is y dot over y? Assuming that a, x1, x2 and x3 are all functions of time. Well, we know that, I'll do one of those, dy dt or y dot equals how much does y change with time? It's how much y changes with a multiplied by how much a changes with time, plus how much y changes with x1 multiplied by how much x1 changes with time, etc. Okay, it's very intuitive. How much is y going to change with time? Well, how sensitive is y to a, and how much is a changing with time? Plus the sensitivity of y to x1, and how much x1 is, and so on. We can do this because we've got a single term here. They're all multiplied together, right? If we had something plus something else, then it's way more complicated, okay? But when they're multiplied together, it looks like this. And how does this work out? Well, dy dA, like an economist, is just y over a, isn't it? And dA dt is just a dot. Dy dx1, like an economist, is 1 minus alpha minus beta times y over x1. And then dx1 dt is x1 dot plus, and so on. Right. So then hopefully you can see with a little bit of thought, if we divide through by y, we get y dot over y is a dot over a plus 1 minus alpha minus beta x1 dot over x1 plus alpha x2 dot over x2 plus beta x3 dot over x3. And again, hopefully once you've done this a few times, you can go straight from this to this, but only if you feel confident. If you're not confident, go through the steps. And I think that is the last slide. Yep, we're at the end of our little math run through, and I got to try to find the stop button.